Talking about this guy.
No, we didn't. Technically, the t squared 5t plus 2.
Right.
Yeah, we did. Yeah. Wait, it was t equals 4. Yeah, it was t. Yeah, t equals 4.
Okay.
Don't forget the
Okay, I'm gonna give you one chance today. I'm getting a little. The chit chat's getting a little old for me. I'm gonna give you one chance to get it going right, and if not, for the first time in my career as a teacher, I'm gonna put a seating chart in the calculus class.
We're a good class.
Yeah, but there's just it was a little too much talking yesterday. It was kind of annoying me a little bit. Okay, so what did we say about this? Right, this was parametric equation, kind of a different deal. You haven't seen these. We'll start seeing them a little bit, but both the x and the y are written in terms of t. Now, here's a way to visualize this. Let's get all headphones and things put away, please. Don't want to see any possible distractions out. Yes?
I think it was t equals 4.
Was it t equals 4?
Yeah.
Okay.
Me too.
No. Okay. So here's a way to think about this. Now, let's look at, like, how about the flight of a football in the air? We talked about projectile motion yesterday. Okay, so if we want to look at this, here's my football field, right? And here's the flight of the football. It's starting right here, and it's just going to go like that, let's say, right? If we wanted to isolate the components of motion, like if we wanted to look at the y component of the football as a function of time, where would I want to put my eyeball? Wouldn't I kind of want to go like that, right? So if the eyeball were looking from this direction, right? That eyeball is going to, ever see that's an eye? That's going to isolate the y component, right? So that would be something like this maybe. Now it's not. I mean, it's different for projectile motion, but you get the idea. If I wanted to isolate the x component, where would I look?
Straight on.
Yeah, like maybe straight down on. I'm not tall enough to do that, but it'd be something kind of like this, right? If I were watching from way up here, right? Then I'm looking straight down on the thing. I don't see the up and down motion. All I see is the horizontal motion. That's a model for a parametric system, right? Where we're just going to isolate. No, they're both changing with time, but they're independent of each other, right? So that's kind of what this is like. It doesn't really have any bearing on how we do the calculus, but I just want you to be able to, have some idea about, why we might talk about something like this. Okay, so what do we say here? What do we say here? If we want to calculate, we're trying to find the equation of the tangent line. Well, I think we found the point of tangency, right?
Yes.
When t is equal to 4, we get x of 4 equals 16,
Y.
and y of 4 equals 22. Okay, so we've got a point of tangency there. We just need to know the slope of the tangent line, right? So to get the slope of the tangent line, that's going to equal dy dx, isn't it? That's going to be the derivative at t equals 4, right? Okay, that was the part where I wanted to make a connection to the chain rule. I think we even got to the point where we calculated dx dt, didn't we, and dy dt? Okay, so remind me, what were those things? Dx dt was 2t, and dy dt is 5, right? Okay, so here's where the chain rule comes in handy. We want to be able to write the derivative dy dx in terms of dx dt's and dy dt's, because that's what we know, right? And the suggestion, a good suggestion was made. Who made that suggestion? I can't remember. It was someplace in here. Somebody told me to take a ratio. Why do we do something like this? We could say dy dt, whoops,
Bro, the clock.
dy dt divided by dx dt. Yeah, that works, doesn't it? Because these derivatives, I mean, they're not technically fractions, but they act like fractions, right? And so the rate of change on the bottom, written in ratio form like this, if I want to make this a product instead of a quotient, I would just flip and multiply. Flipping and multiplying in this case does something interesting. We end up now, instead of the ratio of the rate of change of y with respect to t divided by the rate of change of x with respect to t, we get the ratio, the rate of change of y with respect to t times the reciprocal rate, right? Times the rate, is a little strange, but the rate of change of t with respect to x. And that works because algebraically, the dt's cancel, and that's a good way to organize the chain rule. Okay, so now what, this one we know, right? This one is 5, right? But what's that? Well, dx dt is 2t, but what's going to be dt dx then?
1 over 2t.
1 over 2t. Yeah. Okay, so it works. We could either write this one as,
Wait, why is that?
because if dx dt equals 2t, then, whoops, then dt dx is 1 over 2t, okay? So it'd be 5 divided by 20, right? Or divided by 8, sorry, because t is 8. Now, does that make sense though? If I want to, if I flip a rate, now let's think about this. In terms of the clock example we had, we said, remember, that the rate of change of ds dm, the rate of change of the second hand with respect to the minute hand was 60, right? Because the second hand went around 60 times in the time it took the minute hand to go around once. Okay, what is going to be the rate of change of the minute hand with respect to the second hand? It's 1/60th, and that makes sense, doesn't it? Because wouldn't you agree that the minute hand is going to go around 1/60th of a rotation in the time the second hand goes around 1, right? Or you can think of it as a 1/60 ratio, right? Does that make sense? Because that makes it, so it really does work, doesn't it? If we take the reciprocal of a rate, it should end up being the reciprocal of the value of the rate, right? Because we're interchanging, and we're taking, instead of seconds with respect to minutes, that would be a big rate. The rate of change of minutes with respect to seconds would be a correspondingly small rate, right? Make sense? Okay, so yeah, we can write this either as a product then of 5 and 1 over 2t, or why not just write it like this, right? Why not just write it as dy dt is 5 divided by dx dt is 2t, right? So there's our derivative. Oops, dx. And that's a function of t, as we expected. If we want to know what the slope of the tangent line is at when t equals 4, we just plug in 4, right? So we know that the slope of the tangent line then is 5 over 8 when t equals 4. And that's all we need, isn't it? If we have the slope of a tangent line and we have a point of tangency, which is right here, isn't it? 1622. It's a simple matter to come up with the equation of a line, right? We have a point and a slope. Okay? Make sense?
Wait.
Okay.
Down.
Yes.
Oh.
Okay. I think we did this one, so this will make it this next one. Did we find the second derivative of tangent?
Yeah.
Okay, good. Okay, so then last one, really quick, and then I'll let you go work, is this guy. Okay, what if we have something like this? What if we've got f of u, be careful with that, equals u to the fifth plus 5, and we have u equals g of x equals the cube root of x. Okay, and we're going to take this when x equals 1. What I want you to find here is, now what does that mean, first of all? Just a notational thing. I want to make sure you remember this. Yeah, fog. Yeah, what's fog?
F of G.
F of g, right? That's
Composite function.
good. F of g of x. So we could also write this as, but we're trying to find actually prime. So that's just, fog prime would just be the derivative of the composition, right, of fog. So that's going to be the same thing as saying f prime of g of x, right? Okay, makes sense? So f of g of x is the same thing as saying f of u, right? Okay, so there's a way that we could sort of, there's nothing really profound about this, but I think it helps you sort of internalize the idea that there are links in the chain. So if I want to calculate f prime of u, what's that going to be by the chain rule? Yeah, I'm going to get f prime of u, remember, if I'm going to differentiate this, right? Yeah, I've got to, first of all, I've got to find, let me write this a little different. I want to make one small change here, because I think this is, really what I should do is this. What I should say is the derivative. So f of u prime is equal to what two steps? F prime of u, right? Because the first layer is, the outside layer in this function is an f, isn't it? Right?
Times u.
Yeah, right? So at the outermost level, I don't even care what's in here. I just know that I'm taking the derivative of the outer function, which is f, right? So I'm going to get f prime of u times, if I look inside, u prime, right? Does that make sense?
Yeah.
Okay, so if f of u is u to the fifth plus 5, what is that?
5 times 4.
Good, 5u to the fourth times, I should have probably color coded this, but times, what's u prime going to be? If u is equal to the cube root of x, that's the same thing as as x to what power?
1/3.
Okay, so what's going to be u prime then?
1/3 x to the negative 2/3.
Okay, so that's my answer, isn't it? Right. Now, do I want to leave it like that? No, probably not. Probably we don't want to leave this in terms of u's. We want to write this in terms of x's, right? And so the last step would just be maybe to rewrite this as 5 times, instead of a u to the fourth, that would be what? Yeah, good. The cube root of x to the fourth, right? Because that's u, isn't it?
Yeah.
Times 1/3 x to the negative 2/3. Well, that's the same thing as saying 3x to the 2/3, right? On the bottom.
Yeah.
The 3's on the bottom, and that's a negative exponent, so that gets pushed to the bottom. And so then if we want to maybe simplify this a little bit, it's no big deal. How would I write the top as a fractional exponent? 4/3? Yeah. 1/3 to the fourth is just 4/3. So I get x to the 4/3 over x to the 2/3. So how does that simplify? Yeah, 2/3 on the top, right? 4/3 minus 2/3 is 2/3, and so I would just end up getting 5/3 x to the 2/3, right? But the main thing I wanted to show you is just this idea right here, right? That we don't even really care what u is at this point. U is like hand, right? So f prime of u is just is just gonna be f prime of hand, right? In this case, it's just that, right? Okay. Yes, sir.
Wait, I was looking at the assignment, and how far do you want us to simplify? Do you want us to simplify like all the way down to the bottom part?
Yeah, and this one you could simplify to the bottom.
Or would we be okay just leaving it as 5x to 4/3 over 3x to 2/3?
You'd rather simplify it to here. And it's easy to do this time, right? Because I have like bases. But if on the top that were like an x plus 3 to the 4/3 and an x to the 2/3 on the bottom, you wouldn't do that. But because they're like bases, it's so easy to do, right? Make sense?
Yep.
Okay, so we are in,
209.
I think 209, but we'll look and see.
It's not 205.